Alright, picking up where I left off on creating a subsurface scattering node in Lightwave. Previously, we created a node that shaded one side, the lit side, of our dinosaur green, and the unlit side, or the light shines through the object, is now lit with a red. We have to take a few more steps in order to make this look like subsurface scattering, however. This is more of a modification of the translucency feature in Lightwave, where light shines through and lights the opposite side uh, of a surface. I also created a bend normals function that would let us spread this light out. However, we're going to skip that step for now, since I explained it earlier, and you can probably modify it as you need to for your own needs. That is included in the archive that I put on the New Tech Lightwave forums on the New Tech website. Alright, so the last step was that we created two Lambert shaders, a green one and a red one, and we added them together. The red one uses a surface normal that has been inverted by multiplying it by -1. Our next step is to use the thickness of the object to control this red, instead of just having a blatant red color on the outside of the object. This will give us the appearance of having volume. Although we are technically not ray tracing a volume, we are only passing rays through the inside and letting it hit the opposite side of the surface of the object. But the results are generally pretty convincing. So our next step is to find that, I believe is in the gradients. Let's see, tools, gradients, no, gradients, tools, and thickness. We want to use this to find out how thick our object is from one polygon, the viewing polygon that we're looking at, to the polygon on the opposite side of the dinosaur. And I believe dinosaurs are thicker in the middle than on both ends. I heard that somewhere. Alright, so what we have to do is provide a normal. And if we just use a regular normal, the surface normal, and let's see, take our length, and we're going to multiply, no, I'm sorry, we're going to divide our length by this color, I believe is what we're going to do, if I recall correctly. If we'd multiplied that, well, we'd get the exact opposite of what we want. These areas where there's very little distance along the from one side to the other would be dark, because it's a very small distance, and multiplying by a small number will give you a small number. Where the thicker areas, say it's a meter between there and there, would be very bright, because you're multiplying by 1. Whereas here on the side, you'd be only multiplying by almost 0. What we need to do is the opposite of that, so we're going to divide the surface color by the thickness. So let's find a math scalar, divide, and this has to be a scalar, not a vector. Sorry, this has to be a vector, not a. Let's get rid of that. This has to be a vector, not a scalar, because it's a color. Colors have 3 parameters: red, green, and blue. So let's find divide in here, and we'll multiply our color. This is coming out of the red node, the red insides of the dinosaur, and we're taking the thickness, the length of the distance of the ray travels inside the dinosaur, and we're dividing one by the other. Now we're going to take that result and pass it back into the color, which is added to the green as well. As you can see, lo and behold, we've created more or less a subsurface scattering shader, with one exception. We're not yet actually scattering any light rays. They're just passing straight through. That's why we see these sharp edges, these creases, because you're seeing the creases where the dinosaur's leg connects to the body. You're seeing various artifacts like that. The part here where the torso is connected to the leg, and etc. Well, we need to randomize this as if the light was passing through the object, and once it hits the inside, it starts scattering. So what we're going to do is we're going to take that surface, that random normal, which we already imported, as you recall, And we're going to, let's see, I've actually got two of these thicknesses in here, so I think I must have been demonstrating that earlier. I'm going to delete that. I'm going to unconnect the regular normal that we passed to this thickness, and I'm going to take this random normal. Remember, a random normal that we're using is a completely random normal, averaged, meaning half and half, 0.5 of each of the regular surface normal, which is always pointing in the direction the polygon is facing. So what you get is a semi-random normal, which is always in the hemisphere of the polygon, the vector that the polygon is facing, but it never passes inside the object. The thickness node actually flips the normal for us, I believe, so it's actually inside the dinosaur instead of outside. So we don't have to actually worry about flipping this normal because it's done for us. So I'm going to pass that into the normal of the thickness, and suddenly, if I've done all well, which I haven't, let's see, and I should have an index of refraction. That's one thing we haven't done yet. If you do not have an index of refraction, this is not going to be ray traced, and you're not going to see anything because it's just doing regular transparency. So you actually do need an index of refraction. So let's give it 1.5, sorry, 1.5, and see what happens. There we go. As stated before, we have in fact created a subsurface scattering node. Our light rays are now being scattered inside the dinosaur. We no longer see hard, harsh shapes because the light rays are being bent as they pass through the surface, and they're coming out in random positions on the opposite side. Now, one thing that's somewhat unappealing about this is that just where the green stops, this red starts. And that is exactly why I created that bent normal shader, or that node that we were using before. So import nodes, and let's see if we can get this to work right. Bent normals toward object. And I'm hoping this works. Let's see, we got a normal, we need a world spot, we need a surface normal, we need a reference world point position. That has to be the light. So we need a let's see, we need a item info, which is somewhere around here. We don't want the light info or any of that because it doesn't give us a world position. We want item info, which, let's see, is right there. We want to connect the world position, not just the regular position, but the world position, into reference world position. And we need a value, which should be probably about 0.5, which we'll use this is just a scalar, it's not a vector, so we'll use a constant scalar, which is there. We'll give it whoops, I gotta hit the right keys, 0.5, and we'll take that scalar and plug it into value. Now that should set up our bent normal, and if I've done nothing else weird, let me see, I just need to plug this into what? I believe I need to plug it into this multiply thing. This is where we flipped our normal. We multiplied it by -1, and if I put this here, that should now, let's see. I might have to flip it, and then that might be the key there, is to flip it and then multiply it. So let me see what happens here. I'm going to unconnect that briefly. I'm going to connect that to that. We're getting normal from our original object. Putting it there, and there you go. Finally, we have finally duplicated our subsurface scattering. Now you can see that the red that is passing through the object overlaps the green. It is no longer a straight linear passing through, but it actually spreads out. It flays out as it enters into the dinosaur's body, and comes out wider than when it went in. That's in addition to going in random directions. So the green and the red now overlap, instead of just one being on one side and the other being on the other side. So let me move the light around. As you can see, as we move the light in the front, our object is again mostly green. And if we move it toward the towards the middle, the middle front, you can see the lit areas are still green. The back side is having that red pass through there, and so forth and so on. There's quite a lot more we can do to this, of course. We could have a parameter in there to control the amount of red, which would be nice, and the amount of green, which would also be nice. Say this was half of that, or even less. Let's see how that looks. Something a little odd went went on there, but let's see. Now it looks like it's not a completely opaque surface, but some of the light is going inside the object and not reflecting off the front surface. So actually more light's coming out of the back end than is being reflected off the front. And there's a lot of other parameters we could plug into this. Again, we could create our own shading node by using dot product shading, and we could create our ray trace our own shadows. We could get soft shadows. We could even probably trace a shadow through the object, so we could have a shadow that goes in on one side and comes out on the other side. Quite a lot more that could be done to it, but I'll leave that to your imagination. Hope this has been something you could understand. It does get a little confusing at times, but that's the beauty of Nodal, is it lets us experiment and see our ideas almost instantly just by connecting a lot of arrows together. Brilliant idea. Love it, and guess I'll talk to you later. Thanks for watching, and TTFN.